Good morning. So you miss me that much? Child, Joy miss me so much. She didn't see me. She was worried. She. All right. Don't worry, I'm here. Okay. So we'll start from where we start. Did you collect notes of what we did? Did you? Okay. This is your first time of coming. Okay. Please after today's class, try and collect the notes so you can be on the same page with us. Okay. All right. So what did you do yesterday? Only English. Yeah. Don't worry. Yesterday was somehow. So we are on the topic electrolysis. What's your name? I know Joy. You know his what? Kalista. And you? Ayu. My name is Chetanda. I just call me Chetanda. That's my name. My name is what? Chetanda. This is my contact for those that you see, because Joy has my contact. I said straight in my heart, has. Which one is correct in English language? Yeah, you did in English, has, right? So when she didn't see me, she was like, so I didn't come yesterday. They didn't touch me. I said, no, I must come today. I rushed down. That's good. We are caring, that's good. Are you caring, Kalista?
Yes, I came here yesterday also.
Are you caring that question? Yes or no?
Yes, everyone is caring.
Is that why everyone is caring?
Yes,
all right. So let's go down to the business of the day. All right. So today we start from where we stop. Where do we stop?
Factors of influencing the discharge of ions.
Factors that do what?
Influence the discharge of ions.
Factors that influence the discharge of ions. Okay. So let's start from where we stopped. Did you mention any of them?
Yes, electrode-related factors.
Electrode what?
Related factors.
Okay. So what do you say under electrode-related factors? Don't worry, what you are saying, if you have not got, please remind me your name. Ayo. If you are not comfortable with the topic, what you are saying now will be doing so hard to you. But don't be afraid. Is it jam you want to write or wayek? Jam, only jam. Okay, all of you are only jam you want to write. Okay, good. That means you did science in your Sunday school, right? So, all right. So let's now. We stopped at electrode-related factors, right?
Yes.
The first one is electrode material, right? Good. And we said that the electrode material can be used. The nature of the material used can influence the what? The discharge of what species. And we give an example like inert electrode. Inert means they are not what? Reactive, okay? Inert means that they are not what? Reactive. So inert electrode, like platinum or graphite, they do what? They may not react with the what? Electrolyte. While the reactive ones will react to the what? Electrolyte. Things like copper or zinc, they may participate in the reaction. Platinum and or graphite will not participate in the reaction because they are not what? They are inert. But things, if you use copper or zinc as the electrode, they will participate in the what?
Yeah.
Close that thing. Close it. It will distract you. Close it.
No, I'm trying to open the.
Close it. Please, if you are in class, close your textbook for now. Focus on what the lecturer is saying. Try to take down notes. Okay. When you now go home, you can open your textbook and now start compare and study to help you move. But if there are some things I will say that are not in that textbook and you miss them, but the textbook is your own, you have it is your own, you can open it even in 12 midnight, three of us, but you cannot always be with me, three of us. So why not close textbook and listen to me, take down your notes. Share there's wisdom there. Yes, there's wisdom there, right? Unless I ask you to check something, that way you can now open and check. If not, focus on what I'm saying. So you can make some notes, just down some things, and grab it. That's how to study. how to be in class. Okay, now let's look at electrode surface area, the surface area of the what? Electrode. Let's look at the surface area of the, so you can
You don't give us solution related factors.
no, I said that there are two categories of factors: electrode-related factors and solution-related factors. We are discussing electrode-related factors now.
Okay.
So when we are done with all the, we can now enter. Is it clear now? Good. So we have treated the first electrode-related factor, which is what? Electrode material, the material, nature of the material used in making the electrode. Then the second factor under electrode-related factor, you can put down electrode surface area. Electrode what? Surface what? For those that join us today, please, the way my lecture pattern is that I dictate notes, you put down, I will explain. Okay? So if you see right, you just know that I want to dictate for you what you put down. But if I'm explaining, you can be jotting down by the side what I'm explaining. Some points you grab from my explanation, but I'll give you notes, you put down. That's how I teach. Okay? All right. So now I want us to put down something on the electrode surface area. This factor, electrode what? Surface area. Okay. Now, the surface area of electrode can affect the rate of discharge. The surface area of the electrode can affect the rate of what? Discharge. Full stop. The surface area of electrode can affect the rate of what? Discharge. Hope you know what I mean by surface area. Do you know what we mean by surface area? That one I will explain. Continue. Full stop. Then after the full stop, you write. A larger surface area. A larger surface area can provide. A larger surface area can provide more sites for the discharge. A larger surface area can provide more sites, sites, more sites for discharge. A larger surface area can provide more sites for discharge. A larger surface area can provide more sites for discharge. Comma, increasing the rate of what? Reaction. Comma, increasing the rate of what? Reaction. What does this mean? Let me explain what I mean by surface area. Look at this marker now. Look at this marker. Look at this marker. This marker is just straight like this, right? The surface area is straight around them like this. Two of us, like this now. The surface area of this marker to compare with this bench, this top of this bench is very small. Look at it. Look at it. If this marker is come in contact with this bench now, it's only this place that will be here. It has a tiny, a small surface area. This one also has a small surface area. See the surface area of this book. But see the surface area of this desk. Have you seen it now? So the surface area of this book and this bench, which one is higher? Larger, sorry, the bench, right? This one and this one called the book has a larger surface area. So what are we saying now? If we have a electrode, remember our electrolytic cell is like this, right? Remember, then we have a tiny electrode like this. This is surface area of this electrode, and this is surface area of this electrode. This electrode and this electrode, which one has a larger surface area? This one shade, and this one has a smaller surface area. So this point is trying to tell you that the electrode, okay, which of them from the note I dictated now, which of them will have a higher rate of, would have a higher rate of discharge. This one, see? So the rate of discharge here will be higher than the rate of discharge here because of the surface what area. Remember, if you remember what you did in your rate of reaction in chemistry, there's a topic called rate of reaction. Remember the effect of surface area in rate of reaction. Remember, rate of reaction, the surface area of the reactant, the two reactants, the surface area of their contacts. The larger the surface area, the larger the contact they will have, two of us, and the reaction rate will be what? Very high. That's why sometimes if you want to increase rate of reaction, you grind the thing as a powder, two of us, because powder will create larger surface area, two of us, than just lumps. If the thing is in lumps, the rate of reaction will not be high, because you need to break down first before reaction will do what take place. But if you grind it in powder form, the rate of reaction will be what? Higher. Do you know why? The powder form has a larger surface area than the lump. If you want to make tea now, if you want to make tea, tell me. If you want to make tea and you open the Milo or Ovaltine or whatever brand, and you notice that maybe air has entered or whatever that happened, it's in lumps. And you now want to make it, use it to make tea. Do you think you will enjoy that one that is in lump than the one that is in powder? Which one will you enjoy more? What a shame, because in the contact surface of contact is higher, so it will dissolve easily. You can enjoy your tea. But the one that is lump, you hit it. You want it to break up because you will not the Milo will not come out and dissolve. You may end up drinking ordinary water while the lump is still at the sediment at the bottom of the cup. Will you be happy? So I'm trying to explain surface what area. Alright. Now let's look at another factor. Electrode potential. Electrode what? Potential. Electrode potential. Are we together? Put down. Electrode potential. Put down. The potential applied to the electrode. The potential applied to the electrode. The potential applied to the electrode can influence the potential applied to the electrode can influence are you there? Can influence the discharge of species. Can influence the discharge of what? Species. Can influence the discharge of what? Species. Though that we are okay, I think it was only during that I told you that when I say species, I'm talking about ions, radicals. Remember, ions and what? Radicals. Okay. The potential applied to the electrode can influence the discharge of what? Species. A higher potential, continue, full stop, continue. A higher potential can drive the reaction forward. A higher potential can drive the reaction forward, comma. A higher potential can drive the reaction forward, comma, increasing the rate of discharge. A higher potential can drive the reaction forward, comma, increasing the rate of what? Discharge. A higher potential can drive the reaction forward. Doing what now? Increasing the what?
The rate of discharge.
Now, the very big question I want to now ask: what is now electrode potential? Who can answer that question? Who knows what electropotential is? What is electropotential? That's a very important question. Who can answer that question? What is electrode potential? Any idea? Any idea? What do you answer?
Like the power of electron.
The power of what?
Electron. According to the electrons, like the higher one, the higher one is charged, the lower one.
Okay. You are talking about are you talking about electrochemical series?
Yes.
Is it something with electropotential? You have the idea, but I want you to smoothen your idea. I'm waiting.
According to the electrochemical series, some electrons have more power. Like the positive ions have more power than the negative.
They are in their own.
Yes,
they are in their own category. So if you are comparing, the comparison should be between a particular. If positive, you can compare positive with positive. And continue.
The upper one have the ability to discharge the lower one.
Is that what? Is that what?
Say the upper one can drive the lower one forward.
I can discharge.
Joey, you're not talking. Say something now. I'm listening. Okay. What you answered is electrochemical series. Did you mention voltage? Okay. It has to do with what? The voltage, the potential. Actually, electropotential. Okay, put it down. So that just put it down. Electropotential is the potential difference. Is the potential difference between the electrode and the electrolytes. Is the potential difference between the electrode and the what? Electrolyte. Is it clear? Yes. Of course, when you say potential difference, you know that it is measured in volts. Hope you know. In your physics, potential difference is measured in what? Volt. Hope you know. Voltage. Volt. Right? Hope you know. In your physics, volt. Right? Yes. Volt is the SI unit. Right? Yes. So potential difference is measured in what? Volt. In your physics. By that place we get there when we go to electricity. But just know that it's just the potential difference between the you know that electron movements is from electrolyte to electrode, and from electrode to where? Electrolytes. So, and it's because of this potential difference. This one is higher potential to compare with this one. Difference in their potential that enables electron to move. So, is that different? Is what drives electron movements from electrolyte to what? Electrode, or from electrode to what? Electrolyte. Is that the difference? When you hear the difference, let me just use something to explain to you what you do every day, to explain to you what I mean by difference. If you put water here, put water in a can here, in a bottle, or let me say beaker here, and put water here, and carry maybe that straw, you normally use to drink water, and place on top of the two beakers. They are the same level. Will water flow? Water will not flow. Who among you have seen somebody that is want to transfer maybe what fuel from 1 gallon to another gallon or something like that before. Okay, let me use the one that's common for all of us maybe we have not done that one. If you like, carry hose, put here, water will not flow. Do you know why? There is no difference. They are the same level. If you want to create a difference, potential difference between the two of them, you raise one up. That thing you raised up there, that you created that difference between two of them. That's when water will flow from the one at higher potential. This one is higher now, from here to here. If you bring it down, water will stop flowing. If you raise this one, water will start flowing from this one to the other one. Now, there is maybe here is electrolytes. This electrolyte and this they are not of the same. They are not of the same level. This electrolytes here, the electron here and here are not of the same level. The electron here, maybe from here, whatever electron here is more than here, it will move from here to here. Here, am I communicating? So it's vice versa. So is that a little potential, the potential difference between this electrode and this electrolyte that will make electron to move either from electrolyte to what? Electrode, or electrode to where? Electrolyte. Am I communicating? It's measured in volts. I just decided to explain that. So whenever we mention all those big names, they will not confuse you. They will not do what? Confuse you. Now let's continue. We are done with electrode related factors. Let's look at solution related factors. Number one, concentration of the. Let's look at solution related factors. The first one is concentration of electrolytes. Concentration of electrolytes. Concentration of what? Electrolytes. Concentration of what? Electrolytes. Alright, let's look at it. Put down something. Alright. The concentration of electrolytes can affect the rate of discharge. The concentration of electrolytes. Okay, now, sorry, before we move now, what do you think? If there is higher, if the electrode potential here is high, will it increase rate of the discharge? Yes, it will, right? Good. So now, continue. I said that the concentration of the electrolytes can affect the rate of what? Discharge. Full stop. Then continue writing. A higher temperature. Sorry, what did I say now? Forgive me, please. Please, clean that in, please. Clean that higher temperature, please. My brain is firing. Clean it, please. We are talking about electrolytes, please. Concentration of electrolytes, not temperature. The concentration of electrolytes can affect the rate of discharge, right? Yes. A higher concentration can provide more ions for discharge. A higher concentration can provide more ions for discharge, thereby increasing the rate of reaction. Are you following? I said, where did stop?
The higher concentration can provide more.
A higher concentration can provide more ions. Are you there?
Yes.
For discharge, comma, thereby thereby increasing the rate of reaction. Thereby increasing the rate of reaction. Is that clear?
Yes.
Good. Thereby increasing the rate of what? Reaction. Joy, you were there. What did I say about concentration? What did I say about concentration of electrolytes in terms of ions? Go through your note fast. Don't waste our time. Go through your note. You that copy note, did you study what you copied? How can I copy note? You not read what
I'll study, but
you
I
will.
have chance yet. So what's the question?
We discussed electrolytes, strong and weak electrolytes, and we also discussed what have we seen it?
This concentration of ions in a strong electrolyte. Solution is equal to the concentration of electrolytes. And the concentration of ions in a weak electrolyte. Solution is less than the concentration of electrolytes.
So when you say concentration of ion in electrolyte, we mean that the ions there. Remember what happens in an electrolyte. Remember, a strong electrolyte dissociates completely, right? So if it dissociates completely, that means it will have a higher number of what? Ions, making the concentration of the ion to be what? Very high. True of us. Now the higher the concentration of the ions, the higher the conductivity. Remember, the higher the what? Conductivity. So here now, this now explain now what is trying to let you know is that a higher concentration can provide more ion for discharge. So if there is more ions in the electrolytes, that means the reaction here will be what? Rate will be what? High. The discharge rate will be what? High. Am I competing? Because the concentration for a strong electrolyte, as we say, concentration of the ion is set as concentration of the what? Electrolyte. Am I competing? So, and that means if the concentration of the ion is very high, that means it will impact on the what? Rate of what? Reaction here, which will also be what? High. Am I competing? Am I communicating? So this is how the concentration of electrolyte can affect the discharge of what? Ions. Is it clear? Are you sure? Who is not following us? Who is lost? Please, anytime you are lost, let me explain, please. At least you paid for it. True of us. So you don't allow your money to waste. If you are here and I say something and you find it difficult to understand and you keep quiet, that means you are allowing your money to do what? Waste. True of us. So please don't keep quiet. Ask question. The second solution factor, temperature. Let's look at temperature. Temperature, you're right. Temperature can influence the rate of discharge. Temperature can influence the rate of discharge. Temperature can influence the rate of discharge. Full stop. A higher temperature can increase the kinetic energy of the ions. A higher temperature can increase the kinetic energy of the ions. A higher temperature can increase the kinetic energy of what? Ions, thereby increasing the rate of reaction. Thereby increasing the rate of what? Reaction. Thereby increasing the rate of what? Reaction. A A higher temperature can increase the kinetic energy of the ions, thereby increasing the rate of what? Reaction. Who among you here knows the kinetic theory of matter? Who knows? In fact, let even start from matter. What is matter? Components of matter. Components of matter.
Okay, gas, liquid, and
that one is states of matter. Component of matter. We have states of matter. We have components of matter. We have types of matter. We have what you said is states of matter: solid, liquid, gas. We have components of matter. We have types of matter.
There is compressible.
What are components of matter? Atoms.
Oh yeah.
Ions. Molecule. These ones are the what? Components of types of matter. What are they? Elements. Elements. Compound and what? And what? Mixture. These ones are types of matter: solid, liquid, gas, plasma. This one is a bit above you. Solid, liquid, gas, plasma. These are states of matter. These are types of matter. These one are components of matter. Now, ions. I have a reason for mentioning this. One, to refresh our memory on this, and to talk about ions now, because ions is a component of what? Matter. Ion is a component of matter. Am I communicating? And the ion come from atom by loss or gain of what? Electron. Am I communicating? So these ions now, this temperature say that the higher the temperature, if the temperature is high, the ions will get kinetic energy and they will do what? They will be able to do what? The reaction rate will increase. Now, in kinetic theory of matter, if you remember your kinetic theory of matter, why I mention matter is because ion is a component of matter. So ion is a component of what? Matter. So in the kinetic theory of matter, kinetic energy, average kinetic energy increase with temperature. Am I computing? So if temperature is increased, it will impact on the average kinetic energy of the particles of the what? Matter. And these are the particles of matter, or component of matter. You can call them subparticles or component of matter. Now this one now, we also have subparticles. Hope you know we have subparticles of atom. These ones are under atom and ion. Subparticles besides proton, neutron, electron. But that's not what we are here to do. Those are subparticles. But this one are components. Now this ion now, if you increase the temperature, the average kinetic energy of this ion will do what? Increase. And if the average kinetic energy is increased, then the reaction rate of discharge will do what? Increase. If you
the rate of discharge, the rate of reaction.
That's the reaction here now. What reaction happens here? Is it not discharge? Two of us, which could be reduction or what? Oxidation. Two of us, is there no reaction? Is discharge, but discharge is just a general term. We didn't specify whether it is reduction or whether it is what? Oxidation. So in this case now, the reaction here is what? Is charge. If we not go deep into this charge, we not start saying whether it is oxidation or what? Reduction. Remember the one that should take place at the cathode and the one that should take place at the what? And we discuss that. You should know that right now. We discuss that in this class and it's in your notes. Please get the note and study. I know this what? Good. You got it. Cathode is what? Reduction. Good. because positive ion go to the cations go to the cathode and accept electron, true or false? And electron acceptance is reduction, while the anion go to the anode to give out their what? Electron. And loss of electron is what? Oxidation. So the reduction occurs in the cathode, but the oxidation occurs in where? Anode. Is that clear? Good. Now, so this is how temperature, all these things I use all these things to remind you of those things now, to bring your mind to those topics, and at the same time use it to explain how ions, business of ion with matter, because it's the kinetic theory of matter that explains this increase in temperature affecting the average kinetic energy of the matter. So this is because ion is a component of matter. That's why I broke down these things, and this normally confuse students. States of matter, component of matter, types of matter, they confuse students a lot. That's why I want to explain it. I explained it, and subparticles of atom. Alright, so let's continue. So this is about what? Temperature. Now let's look at the third factor, pH. pH. The pH of the solution. The pH of the solution can affect the discharge of species. The pH of the solution can affect the discharge of what? The species. A change in pH can alter the concentration of what? Ions. Alter. A change in pH can alter the concentration of what? Ions. A change in pH can alter the concentration of what? Ions. Thereby influencing the rate of what? Discharge. Thereby influencing the rate of what? Discharge. Thereby influencing the rate of what? Discharge. Are we there? Thereby doing what?
Influencing the rate of discharge.
Okay, so when we say pH, what do we mean? pH of what?
Of this concentration.
pH of what? Solution, which is what? The electrolyte. Hope you know. Hope you know. Well, if we hear solution here, we are talking about the what? Electrolyte. Hope you know. Good. So a very big question is this: how does this pH now? How does the pH? I know you had the question. How does the pH now affect this rate of discharge? How? Remember, when we talk about pH, we are talking about hydrogen ion concentration. Hope you know. So how does it affect it? How? Who can try? Who can try? I'm listening. Think. I give you 1 minute to think. Take 1 minute. After 1 minute, I will know who. It seems I'll start giving prize here. Great thinker of the day. I give you 1 minute to think. What can tell me what you think? Okay, you know that.
Huh?
Yeah, say.
Calculate the concentration of iron.
Do you want? Sorry.
Calculate the concentration of iron.
Calculate the concentration of iron.
And the weight of the cell.
I say, how does
like the pH is like how concentrated.
is it your brother? You have the same eyes.
Same eyes.
Continue.
Like the pH just like how concentrated the solution is.
Okay, is that what he said?
I don't know.
Okay, continue.
The pH is like how concentrated the solution is. Maybe a change in the concentration of the solution can affect.
Okay. Let me explain. 1 minute has gone. Let me explain. Are we together? Now, you know that this reaction occurs at the cathode and the what? I hope you know. This reaction occurs where? At the cathode and the what? Now, and at the cathode, reduction occurs at the what? Cathode, right? Right? Now, and what actually happens at the cathode is what? Is loss of what? True of what? Is it loss of electron or gain of electron?
Loss of electron.
At the cathode. Hey, what happened at the cathode? What you just say? No. Yeah, waiting for forgotten it. What happened at the cathode? Explain what happened. Reduction. What is that reduction? What happened?
It's loss of electron.
It's not true. Huh?
Why oxidation is?
No, it's not true.
Oxidation is loss of electron.
But reduction income.
Reduction is
Entry of electron now at the cathode. At the cathode now, the positive ion gain electron to get the discharge there as what? As what? Neutral atom. True of us. So is at the cathode, what happens is what? Gain of what? Electron. Now what I'm trying to say is that if the electrolyte solution is if low pH, what does this signify? Signifies a low pH. What does it signify? A low pH. What does it signify? What does it mean in terms of acidity or
okay, it's acidic.
It's acidic, right? If pH is low, that means it's what? Acidic. Am I communicating? If the I follow you. But if the pH is high, is what? The solution is what? Alkaline, right? Alkaline. Maybe above 7, below 7. True of us. So the lower the pH, the higher the what? Acidic the electrolyte becomes. True of us. And the lower that if the do you know the implication of that lower pH and high acidity? It implies higher concentration of hydrogen ion. Am I communicating? Am I communicating? Yes. The lower pH means high concentration of what? Hydrogen ion. Remember your pH. pH is hydrogen ion concentration. Remember negative log of what? pH is what? Negative log of what? Hydrogen ion what? Concentration. Remember. So the higher the pH, the lower the pH, the higher the hydrogen what? concentration. You know, it's negative log. Look up. pH is equal to negative log of hydrogen and ion concentration. So you know this negativity. The lower the pH, the higher the hydrogen ion what concentration. Am I computing? And the higher the hydrogen ion concentration at the cathode, what happens that the higher the reduction rate at the cathode, because the reduction there is what the gain of electron, right? So the higher the concentration of hydrogen ion, the higher the reduction rate gain of electron at that what cathode. Am I computing? Have you ever seen how concentration pH can affect the what discharge? Am I computing? Now I follow you.
I said the concentration.
You know what the pH? If pH is low, the solution is more is acidic, and the concentration of hydrogen ion is higher. And the higher the hydrogen ion, the more the discharge at the what cathode. Am I communicating? Now, on the other hand, the lower the hydrogen concentration, the higher the pH, the higher the pH, the lower the hydrogen concentration, and the higher the hydroxide ion concentration. Hope you know. Then at the anode now, there will be more oxidation at the what anode, because more electron will be lost at the what anode, because there's more hydroxide ion which is negatively what charged. So there will be more oxidation at the what. So there will be more discharge at the what anode. Is it clear? So this is how change in pH can influence the what the discharge rate. Does it make sense? Have I answered the question you wanted to ask me? All right. Now, the next thing I want us to look at, let's look at the presence of impurities. Presence of impurities. Presence of impurities. Presence of impurities. So how does presence of impurities affect the discharge? Okay, put down something. The presence of impurities in the solution, can influence the discharge of species. The presence of impurities in the solution can influence the discharge of species. Can influence the discharge of what? Species. Full stop. Impurities can alter. Impurities continue. Full stop. Continue. Impurities can alter the concentration of ions. Impurities can alter the concentration of ions or react with the electrolytes, or react with the what? Electrolytes, thereby affecting the rate of discharge. Impurities can alter the concentration of the ions or react with the what? Electrolytes, thereby affecting the rate of what? Discharge. Let me explain. If you know, we say impurity, we don't even know. Impurity can be the one that may be busy reacting with the what is present there. True of us. It may be the impurity may be inert. It may just be there on its own. It may also react to the content of what? Even the ions, it may go, and there are some that may go and start forming complex in the ions in the electrolyte. Some impurities may go and start forming complex compound with the with the ions in the what? Electrolyte. So if electrolyte, the ions that was supposed to go to the electrode and get the discharge are busy reacting with the what? Impurity. Would there be enough ions to get the discharge in the what? At the electrode? Would there be there? For example, now you are supposed to go from here to here. Maybe Joy plan is to go from here to here. And because I'm here, I can be here and just stay my lane, and Joy will just pass. Two of us, maybe the director want to see Joy. Joy, come. Joy will stand up to go. I may be here quietly. Joy will just pass. I will not affect. Joy will go on time. Go and meet her very fast and come back. But if I want to come back, I will grab her from the back and hold her like this. Tell me, how fast do you think Joy will get to him? The rate will do what? Slow down. Two of us. In fact, Joy may not even go there at all. Two of us. So this is what happens when there is an impurities inside the electrolyte. They will start reacting. Some will start reacting with the electrolyte, or for forming complexes with the ions. They will not be free again to go and to migrate. Remember that if you pass electric current, they will migrate to where the electrode. They will not migrate because they are busy struggling with what they are reacting with, or they are busy forming different complexes with the impurities. So this is how impurities can affect the rate of discharge. Does it make sense? Remember, everything is taking place inside this electrolytic cell. So whatever, avoid impurities. If you are setting up a electrolytic cell, avoid what? Impurities. Am I completing? Because they may react and form issues. Even though, yes, you use electrolysis to purify substances. Yes, when we get to uses of electrolysis, I'll teach you how to use electrolysis to purify substances. But just to know that if be careful about the impurities so that they will not affect the discharge. Does it make sense? The next one is electrolyte composition. Electrolyte composition. Electrolyte composition. Electrolyte composition. So how does electrolyte composition affect the discharge? Oh yeah, right. The composition of electrolytes can affect the discharge of species. The composition of the electrolytes can affect the discharge of what? Species. When we say composition of the electrolyte, what do we mean? Carissa, when we say composition of the electrolyte, what do we mean?
That's the concentration. The ions that are present.
The type, the component, what it contains. The
yes.
Type and concentration.
Yes, okay. That present in the electrolyte.
All right, right. Okay, continue writing. The type and concentration. Are you lost? Can affect the discharge of species. Can affect the discharge of what? Species. Full stop. Then continue. The type and concentration of ions. The type and concentration of ions. The type and concentration of ions, as well as the presence of additives. The type and concentration of ions. The type and the concentration of ions. The type and the concentration of ions comma as well as the presence of additives, as well as the presence of additives or complexing agents or complexing agents can influence the rate of discharge. Remember when I was discussing the impurities, I mentioned complexes, right? I mentioned some things that can form complex with the ions. Remember I mentioned them. But those things that can form complex in there may come as impurities, as we discussed. Sometimes they may be there intentionally. Sometimes they may be put in the composition intentionally, not just as impurities now. Am I complicating? So that's why it is under composition now. But if they are put there, that means they are no more impurities. If for a purpose, they are not. If they are there for a purpose, they are not in what? Impurities. Okay, but they can appear there as impurities. If it's not what you want, you don't put it intentionally to achieve a particular what purpose. Am I communicating? Yes. Now, when we say composition, we mean, if we say composition of electrolyte, we mean the type of ion there, the concentration of each of the ions, even other things like additives. Additives means other things extra you added for a particular what purpose may affect the rate of what discharge of what at the discharge at the what electrodes. Is it clear? So they can affect it. In fact, it's just the same thing with what happened with impurity, but this time around, those things you put it, additives, what you put in pleasure, additive, what you put in addition. Is it clear? Of course, I have explained the type of ion. There's ions, the type of ion you put there, the type of ion there. If hydrogen and the sodium ion are present, which one will discharge in preference to the other? I so which one? Tell me.
Sodium the sodium is one higher in the electrochemical space.
You say if hydrogen ion and sodium ion are present in the electrolyte, which one will discharge in preference to the other?
Is it according to the electrochemical space?
Hydrogen ion will discharge now, not sodium.
But is it according to the electrochemical?
Yes, now.
But the sodium is one at the top.
The one at the lower one will discharge in preference to the one. Okay. Not for the positive elements I'm talking about now. Is it clear? So hydrogen will discharge. Have you seen it now that this one will affect the concentration and the type of ion there will affect the discharge. Am I communicating? Is it clear? You are lost. I don't know how to help you from, because you were not there when we started this class, and because she has been because it seems she has been studying. That's why she's following us. But it seems you have not been studying. It seems you have not been studying. True of us, don't lie.
Now secondary school they taught us. Well, me, it has been long I've studied that I've forgotten something.
But it's well, you are here to grab it, okay? So where did you get lost? Is it the notes or the explanation? No, I said that the type of ion inside that electrolyte will affect the discharge. Type of ion, and I use sodium ion and hydrogen ion as example. That if you have hydrogen ion and sodium ion in that electrolyte. The hydrogen ion with the discharge, not sodium ion. And she was like trying to find out why. That's what is called electrochemical series, where they arrange some elements, ions, based on their what? Their electropositivity and their negativity. So hydrogen is lower in the for electropositive ones. Hydrogen will discharge before what? You will discharge in preference to what? Sodium. And I also talk about under the component now. We also have the additives. What any other thing extra you added in the electrolyte will affect the discharge of the electrode, and even the presence of complex agent. And I say that. And I say that the compressing agents, the impurities, all these compressing agents may appear as impurity if you do not put them there intentionally. What is impurity? What is impurity? Let me give an example now. If you get soup now, if you get rice now, your intention is to eat rice. Your intention is to eat rice. And you now order another food that you didn't plan to eat, enter it maybe by mistake.
Sometimes you can buy rice, now they can buy
something in chemistry, your target is rice. Any other thing that is not rice is an impurity. But if you put it intentionally by yourself, it's no longer what? It's now an additive. Is it clear? Yes. That's what I was trying to explain. I think any question? If you don't have any question, I think we'll stop here. In our next class, we continue from maybe we go to Faraday's laws of electrolysis. Is it clear? We go to Faraday's laws of what? Electrolysis. After Faraday's laws of electrolysis, we do the calculations there. After that, we now go over to pick some substances and go through their electrolysis, like electrolysis of dilute H2O so forth. You see how it looks like. Is it clear?
Yes, sir.
So I think we'll stop here for today. In the absence of any question, I wish you a blessed day, and God will guide you. Open your brain so that if you read it will enter. So if you read it will enter. So you can smart jam. Alright, see you next time. God bless you.
Thank you, sir.